Hi, my name is Molly Sarles, and I'm a senior here at Sam Houston State University. The presentation I have prepared today is flexure of the coronal suture in response to traumatic forces. So I've collaborated on this project with graduate student Stephanie Baker and Dr. Lewis from the biology department. So human cranial sutures are very important in forensic anthropology for estimating things like age, ancestry, and race, which are all important for determining the identity of a specimen. So cranial sutures, while mostly immobile, meaning they do not move, have the potential to flex under traumatic forces. And although little research has been done on their response to trauma at a microscopic level, we're going to be looking more into that today. So we have 3 human crania specimens, which we have collected from the Southeast Texas Applied Forensic Science Facility, or the STAFS facility, and we had them scanned at the University of Texas High Resolution X-ray CT facility. Of these 3 specimens, there was 1 blunt force trauma, 1 ballistics trauma, and then we have a control specimen which we're going to be testing our data against. We used microcomputed tomography to segment the coronal suture in each specimen and test for traumatic damage at the microscopic level. So we were looking for differences in the total sutural area of the left and right side. So we were testing the left side of the coronal suture against the right side, and we were testing them in each specimen. So the blunt force, the ballistic, and the control. So we have these sutures which are fibrous in nature and have the potential to flex under forces. And what we're trying to assess today is, will the suture move, or will it create a gap or change at all in response to these different types of trauma? If you take a look at figure 1, right where my mouse is, we have figure 1A, which will be our blunt force trauma, our figure 1B, which is our ballistic trauma, and then we'll have C down here, which is our control. So if you take a look over here under the materials and methods section, in figure 2, I've listed out kind of what we have been doing with our samples. So I have figure 2, we have used a Viso software to segment out the suture and create these landmarks. So these landmarks are located along the coronal suture from this point here, bregma, which will be where the sagittal sutures intersect with the coronal suture. So it'll be right here at the top of the skull. And so we have this all the way down from bregma to sphenion, which would be where it's just an anatomical reference point. So we have these landmarks here, and these are all located 5.05 millimeters apart. So each of these landmarks is exactly 5.05 millimeters. And then you'll have a scale bar down here, which is 10 millimeters, just for reference. So if we also take a look at figure 3, this will just be our coronal suture. So this is an example. So this specimen right here, this is our blunt force trauma specimen. This is the left side of the coronal suture, which will be more important later on. But this red line right here just outlines this part of the coronal suture so that you guys can see that. And then also down here on figure 4, this shows our sample measurements. This is what we were going to be collecting later on for the results section. But what we have down here, if you take a look, is we have these white lines at the ectocranial. So this is the top portion, and then we have the endocranial down here. So these white lines are the ectocranial and the endocranial, and they represent the suture width. So overall, we'll be looking at the hollow space area, the suture thickness, and the suture width, and all of these will help determine our total bone area. So this hollow space area, which is our actual suture in these slices, will be outlined or highlighted in red, and then these dotted lines will represent our suture thickness. So like I said, these will all help determine this total bone area that we're going to take a look at later on. And in this total bone area, this is how we'll be looking at how these different types of trauma are are recorded in these sutures. So let's take a look at the results section. So what we have done is we have measured out the coronal suture in each slice. So we took slices of the crania and we actually dropped these landmarks here in figure 2 to determine this area. So what we had found was that there was not a statistical difference in the total bone area. So between the left and right side of the crania in ballistic trauma, blunt force trauma, and in the controls, there was no statistical difference in the area, in the total bone area. However, if you look over here at this first part of the results, this suture hollow space, which is, you'll look down here, this will be the highlighted red portion. This will be the actual area of this suture. We did notice a statistical difference between the left and right side of the blunt force trauma and the ballistic trauma, which is really important for us because that means that we've actually noticed a change in the suture between the left and right side, which we can, for future studies, look into more for helping determine identity, for helping determine what types of trauma the specimen had suffered, which is, I mean, landmark stuff. So if you look up here, we have the control specimen, which has a p-value of 0.44, which will be greater than the alpha level of significance we used, which was 0.05. So this indicates that between the controls and the trauma that there was a statistical difference. So yeah, and you guys can look at all of my data here that we've collected, and then from there determine this areal change. So these preliminary results have suggested that there's no difference, like I said earlier, in the total bone area. However, we did see a difference in the suture hollow space area. So this is significant to us because this shows that there was actually a change with this pressure, which is our hypothesis that we stated in the beginning. So we would like to do future studies and future research to determine the difference between these traumas. So we only looked at the difference between the left and the right side of the crania, but we would like to know in the future how this changes between types of trauma. And we're wondering if we can actually determine what type of trauma simply from these micro-computed samples. And then, so in the future, we also, in this study, we had 3 different specimens. So in the future, we would like to expand our study or expand the scope of our study to further characterize how the microanatomy actually changes in the coronal suture in response to different types of trauma. And maybe in the future, we can also assess different types of trauma as opposed to just the ballistic and the blunt force. But overall, we would like to thank the staff's facility and the UTCT facility for allowing us to use their facilities and their donor specimens. We would also like to extend our sincerest gratitude to the donors and their families for allowing us to continue this research. And I do have my references listed at the bottom of the page on the right, but if you do have any additional questions, feel free to reach out to me. I've listed my email there as well. Thank you so much.